The overall goal of this procedure is to grow iridium oxide nanocrystals on a semiconductor substrate by photochemical oxidation.
Photochemical oxidation, as a synthetic tool, expands the methods by which chemists can create new hybrid materials, taking photocatalyst production to unexplored frontiers.
Our work treats the Achilles heel of cadmium sulfide, which is known to be highly active for hydrogen production, but is hampered by photochemical instability.
Photochemical oxidation, when applied on nanoscale materials with localized charge carriers, can also be exploited for mechanistic studies of redox reactions by simple examination of the products.
To start, first synthesize cadmium sulfide cadmium selenide seeded rods, and then suspend them in toluene solution indicated in the text protocol. Transfer about half of the solution to a centrifuge tube, and add up to a 1/2 volume of methanol to precipitate the rods. Centrifuge the tube at 3400 Gs for 5 minutes. And decant the supernatant. Retain the pellet for later use. Next, add 250 mg of mercapto undecanoic acid and 400 mg of tetramethylammonium hydroxide to 10 ml of methanol in a centrifuge tube. Vortex until all the solids are dissolved. Add the methanol mixture to the cadmium sulfide cadmium selenide seeded rod pellet and shake the tube by hand to fully dissolve it. Allow the solution to sit for at least 1 hour. After 1 hour, split the solution into 2 centrifuge tubes.